Bismillahirrahmanirrahim. Dear students, today we are going to discuss derivative or differential coefficient. Definition: the instantaneous rate of change of a function f of x at a point p is the derivative of the function f of x at that point, which is represented by f prime of x equals to limit delta x tends to 0 or delta x approaches 0, f of x plus delta x minus f of x divided by delta x. If you remember, we write this as delta y by delta x, which is called the average rate of change. Now when this limit is applied on this, it becomes instantaneous rate of change, and this instantaneous rate of change of a function with respect to x is called derivative of that function or it is called the differential coefficient also. So derivative is represented by f prime of x. This is called the first principal rule of derivative of f of x with respect to x. If y is equal to f of x is a function, then its derivative or differential coefficient is denoted by f prime or y prime. This f prime or y prime represent what? Derivative of that function f of x. Now what is differentiation? The process of that produces f prime from a function f is called differentiation. The process of finding derivative of a function is called differentiation. Let us explain instantaneous rate of change graphically. Suppose we have these two x's. This is x prime, this is o, y and y prime, and we have a curve. This is, let y equals to f of x is this curve. Now take a point P here and a point Q here on this curve. Join this P and Q. What is this? This is secant line. Secant line. And we know that the slope of this secant line is represented by del y by del x, which is called the average rate of change. Now let us suppose we draw here at this point P a tangent. You know what is tangent? A line which touches a curve or a circle by only one point and is perpendicular to the radial segment of that circle at that point is called tangent. If we take this point, then we can draw tangent like this. Now this is tangent to this curve P. This touch the curve at point P. This also represent a curve. Now the slope of this tangent line is called what? The slope of this tangent line is the instantaneous rate of change. Instantaneous rate of change. Rate of change. Instantaneous rate of change of a function represent the slope of this tangent line or this tangent line. It gives the exact rate of change. So I think this topic is clear now for you. The tangent line of the graph f of a function y equals to f of x at point this P is the slope having point P having slope. So this instantaneous rate of change is represented by what? By this. We will find by this formula, and this is called derivative or differential coefficient. We also represent it by this in case of y, dy by dx, dy by dx and y prime and f dash of f prime of x. These three are the same thing. This is called derivative. Now we will solve exercise. Exercise 2.2. Question number 1. Use first principle rule to determine the derivative of the following functions. Part A. F of x equals to 3x. So add the increment f of x plus delta x 3x plus delta x. Replace this x by x plus delta x. So it become 3x plus 3 delta x. Now first rule is f prime of x equals to limit delta x tends to 0 f of x plus delta x minus f of x divided by delta x. Now put the values here. F prime of x equals to limit delta x tends to 0 f of x plus delta x value is 3x plus 3 delta x minus f of x value is 3x over delta x. This 3x cancel with this 3. We get limit delta x tends to 0 3 delta x divided by delta x. Delta x cancel with cancel. We get limit delta x tends to 0 3, and the limit of constant is constant. So this is the derivative by the first principle rule. Now try part B by yourself. Part C. F of x equals to x square plus 1. Add the increment f of x plus delta x equals to x plus delta x square plus 1. Expand this x square plus delta x square plus 2x delta x plus 1. Now we know by first principle is f prime of x equals to limit delta x tends to 0 f of x plus delta x minus f of x divided by delta x. Put the values here. Limit delta x tends to 0 f of x plus delta x value is x square plus delta x square plus 2x delta x plus 1 minus f of x value is x square plus 1 divided by delta x. Now now look here. Limit delta x tends to 0 x square plus delta x square plus 2x delta x plus 1 minus x square minus 1 divided by delta x. X square cancel with x and minus 1 cancel with 1. Here remains limit delta x tends to 0. Take delta x common here. So we get delta x plus 2x divided by delta x. These two cancel. Here remains limit delta x tends to 0 delta x plus 2x. Now put the limit here. 0 plus 2x which equals to 2x is the answer. Try part B D.